Welcome to Sampling Design for Carbon Measurement. In this video, we'll walk you through the key terms and concepts you'll need to understand before starting a carbon measurement project, and then show you how to apply them through real-life inspired examples. Throughout the video, we'll refer to the accompanying guide, Carbon Measurement Sampling Design, where you can find more details about the process. What is sampling design? In a carbon measurement project, a sampling design is the plan for how you collect data from a carbon pool. It helps you decide what to measure, where to measure, and how to get an accurate estimate of carbon stored in a larger area based on a small set of samples. A carbon pool is a system that has the capacity to store or release carbon. Examples include soils, plants, and the air. To keep things organized, your project area is divided into different parts. The study area is the full area where you want to estimate carbon. It might include a mix of ecosystems like forests, wetlands, or grasslands. Within that, you choose study sites, smaller areas where you'll collect data. And finally, inside each site, you have plots. These are the exact spots where sampling takes place. A sampling strategy is how you decide where to place your sites and plots. There are 4 common strategies. With random sampling, plots are selected randomly throughout the study area. This is best when the area is fairly uniform or you don't have much information about it. Systematic sampling is where plots are spaced out in regular intervals, often using a grid. This works well for small, uniform study areas. With stratified random sampling, the study area is divided into study sites based on characteristics like land use or ecosystem type. Then, random plots are placed within each site. This approach is great for larger areas with lots of variation. Finally, convenience sampling is where plots are chosen based on how easy they are to access. It's a good choice when time, budget, or staffing is limited and where data won't be used for reporting purposes. Plots come in different sizes depending on what you're measuring. If you're measuring trees that are taller than 2 meters, you'll need a 400 square meter plot. For smaller plants, you can use much smaller plots, anywhere from 0.25 to 100 square meters. If you're measuring multiple things, like trees and soil, in the same area, you can arrange your plots so the smaller ones are inside the bigger ones. That's called an integrated plot design. You also have to decide if your plots will be single-use or permanent. Single-use plots are sampled once, and that's it. Permanent plots are used again and again, so you can track changes over time. A quick note regarding permanent plots. If you're doing anything that might disturb the site, like digging soil samples, do that just outside the plot area to keep it intact for future visits. Depending on your goals and resources, your project will follow either a Level 1 or Level 2 approach. Level 1 is simpler. It's great for small community projects or when time and resources are tight. The data is helpful but not detailed enough for formal reporting. Level 2 is more advanced. It gives you higher accuracy and is often used when you need to report to funders or participate in a carbon crediting program. It requires more planning and capacity. Refer to the guide Carbon Measurement Sampling Design for details. Other things to consider before you implement your sampling design are the total size of your study area and the carbon pool or pools you're interested in. These factors will impact the sampling strategy you use and your budget. For small study areas, you can use drone or ground surveys to gain an understanding of the landscape variation. But for larger areas, you'll need mapping software. Now that you're familiar with the key terms and ideas, let's walk through how to actually apply a sampling design by following 2 case studies inspired by real-life examples. Pine Valley is a small community with forested land that overlaps a local trail system. Their lands and resources team includes just 2 staff, and they're beginning to explore carbon measurement for the first time. Earth Trackers is a conservation organization planning a long-term carbon monitoring project on an area that overlaps a provincial park. They're working directly with the provincial park and guardians from the First Nation on which the monitoring will be taking place. We'll follow both teams as they work through the 7 steps of designing and applying a sampling strategy. Step 1 is to define your study area. You'll want to use mapping software to determine the total study area in kilometers square. The accompanying guide has information on all the tools required for this step. Pine Valley used Google Maps to draw their area. It's straightforward and easy to share with others. They defined a study area of about 8.5 square kilometers. Earth Trackers used Google Earth Engine, a more advanced tool to define their area. Their study area is much larger, 96 square kilometers. Step 2 is optional but helpful. Stratify your area. This means dividing the study area into smaller zones based on characteristics like land use, ecosystem types, or traditional knowledge. Pine Valley decided to skip the step for now to keep things simple. Even though it limits their sampling strategy options, it still allows them to reach their carbon measurement goals. Earth Trackers consulted with the First Nations Guardians and used local knowledge and mapping tools to divide their area into 2 study sites. One where traditional harvesting has occurred and one where it hasn't. In Step 3, you figure out how many plots you need. Both teams used the sampling design tools from WWF-Canada's Learning Library to help with this. The tool's embedded calculator gives you an estimate of how many plots are needed using just the size of your study area. It also includes a setting called allowable error. That's the range you're comfortable with between your estimated carbon stock and the actual value. A lower allowable error means you'll need more plots to get a more accurate result. Refer to the guide Carbon Measurement Sampling Design for details. This step is required for Level 2 projects like Earth Trackers, but offers Level 1 projects like Pine Valley a helpful frame of reference when planning plots. Pine Valley went with the default setting of 20% allowable error and found they needed 8 plots. Earth Trackers wanted a bit more accuracy, so they set their allowable error to 10%, which meant they needed 52 plots in their larger area. Step 4 is choosing your plot locations. And this is where you choose one of the 4 sampling strategies. Pine Valley chose convenient sampling, placing plots in easy-to-access areas. This made sense given their team size and terrain. Earth Trackers chose systematic sampling, spacing plots evenly across their 2 strata to get consistent coverage. Both teams used the sampling design tools from WWF-Canada's Learning Library to lay out their plots. Step 5 is selecting your plot design. Some decisions you'll need to make at this point are the carbon pools you're interested in, whether to use single-use or permanent plots, and whether integrating your plots makes sense. Pine Valley decided to measure both trees and smaller vegetation. They used an integrated design with different sized plots in the same site. Since they're not planning long-term monitoring just yet, these were single-use plots. Earth Trackers also used an integrated design, but because they plan to return each year, they set up permanent plots. To protect those areas, they took soil samples just outside the main plots. Step 6 is where you head into the field and start collecting data. For more information on field protocols for trees, non-tree vegetation, peat soils, and non-peat soils, take a look at the guides in our learning library. Pine Valley decided to measure both trees and smaller vegetation. Earth Trackers followed similar ones, but also included soil sampling. Both teams recorded their measurements using data sheets and followed guidance based on the carbon pools they were studying. Finally, Step 7, reporting your results. Refer to the guides found in our learning library for steps on how to determine estimates for the average carbon stock and total carbon stock of your study area. Pine Valley organized their field data in a spreadsheet and began sharing early findings with their community. They're planning to expand to other areas in the future. Earth Trackers created maps and a written report to share with community members and partners. With funding in place for the next few years, they're setting up a system so that the area's First Nations Guardians program can track and report results over time. And that's how you go from a blank map to a complete sampling design for carbon measurement. We hope Pine Valley and Earth Trackers gave you a clear idea of how sampling design can work in different contexts, depending on your goals and resources. Congratulations! You now know how to design sampling for carbon measurement. In this video, you covered defining study areas, sites, and plots, selecting a sampling strategy, choosing plot types including single-use and permanent plots, and considerations for reporting and assessing your data. For more information, please consult the accompanying guide for sampling design and refer back to this video anytime. Happy sampling!